Hi, I am Jens Alfke. I'm a mobile architect here at Couchbase, and I'm going to be talking about Couchbase Lite, how to get the most out of it, some good things to know from a performance perspective, and how to make your app run faster and better. Topics I'm going to be covering are some things about querying, especially query optimization and using live queries. I'm going to talk about pre-built databases packaged inside of your app, which can be a big savings in initial launch time of your app and bandwidth. I'm going to talk about multi-threading techniques, how to effectively make use of the CPU cores that you have on your devices, and also about the cblight command line tool, which is a really useful tool for inspecting and querying databases that I think more people should know about. So let's get going. All right, first topic is querying. So I'm going to go into some stuff about how indexes work, which is similar to the way indexes work in a typical relational database. So some of you may know this, but I found in answering forum questions that a lot of people don't know this stuff, and it really gets in the way of understanding how to make queries run fast and what kind of indexes to use. So I think it's a really valuable thing to cover. And I'm also going to talk about live queries, not so much how to use them, but some knowledge of what's going on under the hood so that you can take advantage of them and make them not slow down your app when they don't need to. All right, the query optimizer looks at your query as a parse tree, basically. And it will try to structure, especially the where clause, the thing that tells it what documents to look at. It's going to break that up into a series of and connected clauses or conjunctions. And there's going to be, 0 or more of these, basically. So if you have multiple things connected by and, they're going to form one of these. And so in the orange boxes here, we have 3 things, an equality test on one property and inequality tests on 2 other properties. And the query engine will tend to group these together, and it will use those to try and find a set of documents using an index. And the indexes, of course, are what makes a query fast. What we ideally want to have happen is that we want to let the query engine zoom down the index using the B tree to find the rows that it needs in O of log n or n log n time. The less good approach is if it has to scan the whole index, which is kind of brute force, but it does have the advantage that the index is a lot more compact than the database is because it's only got 1 or 2 or 3 different property values in it, not everything. And the slowest technique is when it can't use an index at all and it has to just scan the database. And that involves loading every single document into RAM one after the other. That's the thing that you really want to avoid if your database has any size to it at all. Let's zoom in on what an index looks like. This is really valuable to know. And as I think I said earlier, not enough people know this. So really an index is very simple. It's just a set of rows. You can almost think of it as being like, a SQL database table that just contains 1 column for every property that you told it to index in order, and another hidden column that contains the document ID, so that once it finds a row in the index, it can jump to the document that it came from. And of course, the index is sorted. That's what makes it magical. So if we look through here, the A column, these values are sorted as we go from top to bottom, 0, 1, 2, because that's the primary key. And then B and C are secondary keys. But if you look at B and C values going down, they're not in order. They all kind of, they go up and then they go down because they are subject to that A value. But if we look at within one A value, like all the values with A equals 0, the B values are sorted. They are increasing 0, 1, 2. And again, if we look at A equals 0 and B equals 0, then the C values there are sorted. And really, this is just another way of saying that the table is sorted by primary, secondary, et cetera keys. But it has some real implications for the ways that the index can be used to satisfy queries. So let's take a look at these things on the right. The green expressions are ones that the index can be used most effectively to find, that kind of jumping down the tree rapidly to the rows that are of interest. The red ones are not. Let's look at these. So if we say A equals 1, then the query engine just jumps through the tree to find the first entry where A is 1, And from there, it can just keep scanning row by row until it hits a row where A is not equal to 1 anymore, and then it stops. Very easy. A greater than 1 is almost the same thing, except that it keeps jumping down the tree till it finds the first entry where A is greater than 1, where it's 2, and it just keeps going till the end of the index from there. Now, if we want to search for A equals 1 and B equals 2, it's the same technique, but the comparisons are starting to involve 2 columns. So it's going to go down the tree to find the first row where A is 1, and within that where B is 2. So since the rows are all compared across all 3 of them, it's really the same kind of simple tree search going down the tree. And from there, it keeps scanning until it hits a row where where A is no longer 1 or B is no longer 2. And again, we can get a really complicated one with A equals 1 and B equals 2 and C equals 3, which is the same thing, just extending it to the third column. We're looking for that first row where all 3 of those conditions hold, and then scanning until they stop holding. Inequalities work too. So if we scan for A equals 1 and B less than 5, then it's the same initial scan as for A equals 1. And then we just keep reading rows until we find a row where either A is not 1 or B is greater than or equal to 5. So now let's look at the ones that don't work. These are ones where the query engine is not going to be able to use the index effectively. It might decide to just scan the entire index, or it might give up completely and just go to the database. So if we're looking for B equals 1, the index does have the rows where B equals 1 in it, but they're not next to each other because the primary key is by A. So this index is really not going to be useful for that. It would have to at least scan the entire index to find those. If you want to say A is greater than 1 and B equals 0, then again, the same thing happens. It's going to scan to the first row where A is greater than 1. But then the B equals 0 rows in the rest of the index are not consecutive. So it can't really find them effectively. It might still be more effective than just brute force scanning, but it can't just find exactly those rows. And again, if we're testing for A equals 1 and C equals 0, there's no test on B here, so the C equals 0 rows are sort of scattered around. And then finally, if we have A equals 1 and B less than 5, we can do that, but then we're going to be potentially going through a bunch of different B values, each of which has their own range of C values. So the C equals 3 values are not next to each other. So that one, again, is not going to work. The general principle here is that as you go from the primary key to the secondary and so on, the first of those have to be equality tests, and then the last one can be an inequality. But if one of them is ever an inequality, you can't have any tests after that. They won't be effective. There are some other kind of comparisons that you can do in a database besides just greater than and less than, of course. One really common one is like, and I've seen people sort of misusing this, or at least having misleading expectations about performance. So the rules that a like can be indexed only if it's a prefix match. So if we look at this, this like test in the middle of the page, like phone, comma, 408-%. That percent is the wildcard, of course. So this really means that the string, the phone property, begins with the string 408-. And we can in turn expand that to mean that the string is greater than or equal to 408-, and it's less than or equal to 408- followed by the maximum possible character value, which, since this is Unicode, is a little weird. It's this X thing there. But that's a range expression. It's a common, it's a greater than, or equal to, and a less than or equal to test. So we can find that in the index. So yeah, it would just be a range of values once it finds the first one that starts with 408. So that test is effective. If there's anything after the wildcard, the index isn't going to help with that. But what's going to happen is that the query engine will find all the rows that start with that prefix, up to the wildcard. And then it has to run all of those rows through the full expression to see whether they match it before it can pass them through. So it's okay. The worst case here is if the pattern starts with a wildcard and then the index really can't help at all. The query is reduced to doing brute force through every document, or at least every document that has such a property in it. Another thing worth pointing out is that the pattern has to be a constant. So it has to be known at a fixed thing at the runtime. There are some cases where you might want to put the pattern into the document, and of course that is not going to be very effective to search for. So some other kind of more general purpose tips. Really be careful about narrowing down your query to just the information that you need. Don't ask for every property of the document if you don't need them. Just look at what properties do I need, or sub-properties, do I need for processing this query, and then use only those in the result of the query. You could consider fetching details lazily. So one technique that can be effective is you don't ask for anything but the doc ID. And that is going to return a very small amount of information. And then you can go and maybe individually load documents just using the document API, or you could run a query that loads information based on a set of those doc IDs, like an array of those doc IDs. Paging is also a very common effective technique. So if you've got a table view and you might potentially be displaying 100,000 documents in that table view, it's probably not a good idea to run the entire query and get all 100,000 rows in memory at once, because that's going to be slow, and just the whole time that that's around, it's going to be using up a lot of RAM storing the query results. So what you might consider doing is just look at the position of the table, the scroll view in the table, and only get the first 20 values. Or you can use the offset to get a subset of the values. So you can do like offset 100 and then limit 20. That starts to become ineffective at very large offsets though, because the query engine does have to actually find those rows and throw them away before it gets to the offset. There are some more advanced techniques involving keeping track of the range of search keys or that you're using. There's not really time to cover them here, but you can find that in probably most books that talk about query optimizations and query paging, since these techniques are going to be the same as in a SQL database. Also, in designing your document schema, consider that smaller documents load faster. It's obvious. So we do allow you to put up to about 20 megabytes of data in a document, but that does not mean that you should be doing that. And I usually advise to keep your documents much smaller than that unless you have a really good reason, just because any kind of a query that is not satisfiable by an index, and you may need queries like that sometimes, they're going to run much faster if the documents are smaller. And also just loading in document is going to be faster if the documents are smaller. So you can break your data up into smaller pieces and have links in between them to make sure that your documents don't become too huge. And instead of having a gigantic array of stuff in one document, consider breaking those out into separate documents that all point back to the first one. And going back to the like expressions and also regex, which has very similar issues. Often I see people using those for something they really should be using full text search for. So if you find yourself looking for a particular substring, as long as you can separate that substring with white space, you can use a full text index to index that property and do a much more efficient search for that word. Another technique that could be useful, this is like when you're trying to troubleshoot and figure out why a query is slow or how to make it faster, is to use the explain method on the query class. What this does, it dumps out a couple things. Some are more useful than others, of course. The first one is the SQL or SQLite form of the query, which might or might not be useful depending on how much you want to figure out about how our query translator works. But the part in the middle is really great. This is the query plan produced by SQLite. And the key things to know about it are to, when you see the word search, that's good. Like search index or search table means that it's using that B tree to its best advantage to jump directly to what it needs. Scan index is that middle case that I talked about where it does have to brute force through the whole index, but at least it's not going through the entire document. And scan table is really what you want to avoid. That's when it just gives up and it has to search every document one at a time, checking to see if they match. So in this example that I have here, you can see that we've got this scan table in there, meaning that we definitely need to do some optimization, probably some indexing on this query. It also has some interesting things here. It says use temp B tree for group by and use temp B tree for order by. And that means that in order to satisfy this group by clause, it needs to internally sort the array, the values into a different order than they came out of the index or the database, so that I can coalesce the ones that match. And then in order to return the results according to the order that we specified, it's got to again sort them into that order. And cblight tends to use an internal B tree, either in RAM or on disk, to do that. And that is necessarily going to slow down the query. But if that's what you need the ordering to be, then there's not really a good way around it. Although you might consider, do I really need the results in that order? Oh, finally, the bottom part of that query is the JSON form of the query, which is sort of the internal form that Couchbase Lite passes it to our own internal query engine. The cool thing about this is that you can copy that and paste it into the cblight command line tool, which I'll talk about later. So you can actually get that query and run it in the tool and then start tweaking it there. Okay, now on to live queries. I think most of you know about these because they're very, very useful for building things like reactive user interfaces, especially for tables. You add a listener to a query, and from then on, the query will get run in the background, and anytime the results change, your listener gets called and you get the new results. This is great, but it is a bit expensive and not magic, so you should be aware of that. Here's the algorithm in a nutshell. On the left side, the green boxes are what you're doing and what you see, and on the right is what's happening down inside of Couchbase Lite. So you create this query and you add a listener. And that triggers Couchbase Lite to run the query. It does this on a background thread. There's a single background thread per database instance for doing this. Once the query finishes, it calls your listener. So you get the initial results. And from then on, this task on the background thread waits for the database to change. And anything that causes the database to change, any update to a document, will wake this up and it will run the query again. And then it will compare the new results it got to the last results that it got. And if they're different, it calls your listener again. And then it goes back and waits again for another change. So yes, what that means is that anytime documents change in the database, your query is going to get run again, which is somewhat expensive. The good news is that we debounce it, which means that if there are several changes in rapid succession, then the query still only runs once. I don't remember the window exactly. It's on the order of like 100 or 200 milliseconds. And this isn't directly affecting your threads because it runs on a background thread. But the bad news is that, of course, running this query does consume CPU time. It does take up I/O to the storage, so that may indirectly affect you. It can slow down other things that your app is doing, especially accesses to the same database. Also, those query results are hanging around in RAM because it has to buffer them to compare them against the next ones. And if your query results are extremely large, then that amount of RAM usage might cause issues. So here's some advice. First, of course, just optimize your queries because the faster they run, the less impact there will be. Remove those live query listeners whenever they aren't needed. So particularly if that view that has that, that page in your UI that has that table view or whatever, if that's hidden, then stop that listener, take out that listener. The view itself might not have been torn down yet. The chances are the UI framework is still keeping it alive so it can switch back. But if it's not on screen at the moment, it's probably better to turn off that listener. And generally, just be aware of how many listeners you have. You might want to kind of wrap your listeners in some kind of logic that keeps a running count or logs or something like that, because it might otherwise be surprising. You should try to avoid live queries if you have queries that are really slow or have huge result sets, or at least stop them running after the initial result comes in, because that might have an effect on your app. You might want to degrade your UI somewhat, like not update things immediately if it's too expensive to do so. And if you're making a series of changes over time, like over a matter of seconds, like for example, if you're running an import process where you're kind of like slowly reading all the data out of a file and copying it in, you might want to turn off listeners doing that, because otherwise they might trigger several times during that process and slow down what's going on. Large database pulls can have the same effect because they are bringing in documents. So if you know that a large number of documents are going to get pulled in, you might want to pause some of the less important live queries if you need to. All right, let's move on to pre-built databases. So the idea here is that it is more efficient, just because the replication protocol is fairly complex, it's more efficient to just bulk download data in like, a direct TCP or HTTP stream than to have it pulled down by the replicator if there's a lot of it. So to save on the initial launch time of your app, you can include a snapshot of the database in the app at the time that that's a snapshot at the time, of course, that the app was built. And then the initial replication will just have to pull down the documents that have changed since that time. So the procedure for this is that you do this in your build and release process. So this will probably be happening on a build server if you're automated, or maybe you do it by hand. You create a fresh, empty Couchbase Lite database, and you pull your sync gateway database into it. You can either use the Couchbase Lite API directly, the same way that you would in your app, or you can use the cblight tool for this. It's very useful for that. Make sure that you use the exact same URL so that later on when the app is using your database, that it can tell that it's supposed to be the same replication. And then create indexes. This is best done after the pull. So create the indexes that your app will use so that the app doesn't have to spend time doing that itself. And then take the resulting database, that .cblight2 directory with the stuff in it, and copy that into your app package somewhere. You might zip it up if that's useful for you, but it depends on how your app is packaged. So on the first launch of your app, you just need to change your logic a little bit. Before opening the database, check whether it already exists. If it doesn't exist, or if you otherwise know that this is the first time the app has been launched, you will go and locate that prepackaged database inside of your app bundle, your app package, and call the static method database.copy to copy that from there into the usual place where your mutable database will live. It's very important that you call that method and don't use the file system to do it directly. Then you open the database as normal and go about your business, and including starting a pull replication to catch up. The pull replicator will end up using the checkpoint that's in that prepackaged database as the timestamp of where to start from. So it will only need to pull in the documents that have changed since that time, which is a lot less. If you can, try to start immediately without blocking for that replication to complete. It will make the first launch experience a lot nicer if the user doesn't have to sit there with waiting for some kind of progress indicator to finish. You may have obsolete data at first, but that may be okay. And then the new data will kind of start appearing and filling in as the replication proceeds. There are a couple ways this can go wrong. The worst problem is if you, during your build process, I said to create a fresh database. If you don't do that, if you just keep the database and then use it the next time that you build, version n.1 of your app, bad things will happen. And in a nutshell, the checkpoint in that database and on the server side will get messed up, and it will stop the app clients that were using the earlier version of your app from being able to take advantage of that checkpoint. They will end up pulling everything in. So don't do that. Always, delete any old database, create a new one, and then do that filling in process on the server. The second problem is if you copy that database file manually out of the app package. And again, it will mess up the checkpoint and cause problems. So I don't want to go into the details because they're confusing and kind of distracting, and you don't need to know them. You just need to know, hey, don't do that. The third way it can go wrong is if that initial replication doesn't use the same parameters that the actual application replication will use. So if the set of channels that you're getting or the replicator URL don't match, then it's treated as being a different replication with its own checkpoint, and it will, again, have to start over. All right, next topic is multi-threading. So obviously the devices people are using now tend to be pretty fast. They've got several CPU cores, and we would like to make use of those, and we would like to avoid blocking the main thread and keeping the UI responsive. So the first level of things to know about multi-threading is that Couchbase Lite objects are thread safe. So you can concurrently call the same database, the same document, et cetera, on multiple threads without crashing or corrupting memory. But if you've done any threading, you have probably already learned or figured out that mutating the same objects on multiple threads is usually bad news. So in things like if you have the same mutable document reference on multiple threads and make changes, you can get in trouble because the threads could, step on each other's changes. They might happen in the wrong order. One of them might save it before another one is done. So it's generally better to create a separate mutable document instance on each thread that needs to use it. Same thing happens with query parameters. That's the kind of mutable part of the query object that can plug in values to use when running the query. If you've got multiple threads running the query, they might try to plug in different parameter values and step on each other and get mixed up. And again, with the query result set, that's an iterator, and stepping an iterator on multiple threads is just really going to confuse everyone. So use separate instances per thread for that. Now, a performance caveat about this is that the Couchbase Lite objects, they are thread safe, but they tend to run single-threaded. In particular, the database object is single-threaded. You can think of it as like every public API call is going through a mutex belonging to that database object. So the database can only do one thing at once. And that extends to most of the classes that do things to the database, like a query object or a document. So you can run one query at a time. If you try to run a query on the same database instance on two different threads, one of them will block till the other one finishes. And similarly, if one thread is saving a document and another thread tries to save a different document, that second thread is going to block until the first thread is done, because the database can't be saving both of those at the same time. The database object can't be saving both of those at the same time. The workaround for that is using multiple database objects. So you can open as many database objects as you want on the same database file. You just use the same database name or the same path. And those can work more concurrently. And typically it can be a good pattern, like if you have a couple of worker threads, to have each of them open its own database connection so that they don't end up blocking on each other's mutexes. So you can save, well, not save, but you can run a query simultaneously in two threads, for instance, if you do that. There are a couple things to watch out for if you start doing this, though. If you're changing documents on multiple threads, then conflicts are more likely to occur. So for instance, if you have two threads that are each making changes to document A, and then they both save, one of them is going to save before the other, even if they're using different database instances. And depending on your concurrency mode, different things will happen. So you really want to avoid that last right wins model. It's very convenient, and that's why we have it there, that it's, for a single threaded app, that just makes the most sense to do. Multi-threads, it just means that one of the threads is going to step on the other one and probably lose changes that the other thread made, if they overlap that way. The better modes to use are the one where you will get a conflict error, and then you can retry after reading a new version of the document to pick up the changes. Or you could just use the newer mode that was introduced in 2.7 that gives you your own conflict handler so that you can have that handler be invoked and make the necessary changes to merge your changes with the pre-existing ones. Also be aware of what threads listeners are getting called on. Typically, and this varies by platform, but typically those are going to get called on the main thread, which makes sense if you're doing your work on the main thread. But once you start getting into multiple threads, you need to be aware that the listener may not be running on the same thread that you're doing your work on. And you want to avoid accidentally like shooting yourself in the foot by doing thread unsafe things with your own code, or doing something that blocks and blocking Couchbase Lite if it's waiting for your listener method to return. One of the best things you can do, and again, this varies by platform, is to tell the database or the query or whatever what thread or dispatch queue to call listeners on, and set that to be the queue or thread that you're doing your work on. And that way you won't have problems like that. So as I said, there are some limitations on concurrency. Even if you have multiple database instances open on the same file, the underlying storage engine, which is cblight, only allows one writer per file at a time. That applies to any operation that changes the database. So that's like document.save, purging documents, the in-batch call, which will do a whole bunch of changes inside of one at once. So if one database connection instance is in the middle of a write, then any other database instance that's using that same file will block when it tries to write until the first one finishes. So you can't do two saves concurrently, even by creating multiple database objects. But writes don't block reads. So if you're in the middle of a save on one thread and another thread starts a query, that query will proceed. It will essentially be looking at a snapshot of the database in the form that it was when the query began. And of course, as I alluded to before, there are just limitations on the hardware. So I/O bandwidth will definitely come up if you're doing any kind of expensive operations that do a lot of fetches or saves. So, you know, your main thread, your operations may slow down because one of your other threads is doing a lot of stuff, reading and writing. There's only a finite amount of CPU power on the device. So even with multiple cores, you know, the background operations might be starving other threads. And every database connection opens, it allocates a couple megabytes of memory for a page cache. So that memory may add up if you open a lot of connections. I don't recommend opening up like 1,000 database connections because that will be quite a lot of RAM occupied for those page caches. There are some things that you might think that multiple databases would help for, but they actually don't because we've already thought of this. So replicators, you don't need to open a separate database, you know, or separate thread to run a replicator. The replicator already, the first thing that it does is opens a new database object on that same database file. And it does everything using that object so that it can be as separate as possible and take advantage of concurrency. The only thing the replicator does on the main thread or your thread is to call your listener methods. So other than that, it's not getting in your way. And a very similar situation with live queries. As I described before, every database has a background thread that's reserved for running the live queries. So that query is not going to be directly blocking anything that your application is doing. All right, so last but certainly not least, the cblight command line tool. This is a tool called cblight that is not an official product, but we use it ourselves and it's really useful, and a number of other developers use it too. So it lets you inspect, browse, query, you can run the replicator, you can import and export JSON. Oh, sorry. Yeah, nope, there we go. That is the URL from which you can download a binary release. It is open source, but we recommend downloading a binary. It's just easier than building it yourself. And the binary was built with the Enterprise Edition Couchbase Lite so that it can open up encrypted databases. And otherwise, you cannot yourself build the Enterprise Edition from source. Installation is really quite simple. Once you've downloaded it, you just put it somewhere, that it'll show up in your shell's path so that your shell can find it. Using it, it's one of these tools that takes a subcommand as the first argument, sort of like Git and a bunch of other programs. So you can either use it one shot by saying cblight and then the subcommand name and then the path to the database, and it will do its thing and then return back to the shell. Or, and this is what I more often tend to do, you can run an interactive mode where if you don't give it a command name, so the first argument is just the path to the database, it goes into a little shell of its own where it puts up its own cblight prompt and lets you type in commands. And those are the same commands, it's just you don't have to type cblight again and you don't have to type the path to the database every time. And as usual, you hit Control-D, end of file, to escape from it back out to the shell. There's a help command, of course, just cblight help will list all of the commands that are supported. And you can type help and a command name to get more information about that. This is the current output of the help command. So as you can see, there's quite a few commands in here. And what I'm going to do is go through not all of them, but most of them. There are quite a lot that are typically useful. And I'm not going to do a live demo. I'm sorry if that disappoints anyone, but I always find demos where somebody's typing into a terminal to be not very interesting or enlightening. And I'm one of those people who, if anybody is watching, I will make 10 times as many typos as normal, which makes it really frustrating. So instead, over on the right side here, I'm going to have a sort of imaginary demo that shows what I would have typed and what the results would be on the travel sample database, which is one of the sample databases that comes with Couchbase Server. So the first command we have is info, which just dumps some information, some fun facts about the database, the file size, the number of documents, the UUID of the database, things like that. It can also be used to see what indexes there are in your database. The check command runs an integrity check. It literally calls SQLite's Pragma integrity check. So database corruption is really, really unlikely. The only thing really that will make it happen is if your media gets damaged. That could happen with SD cards because SD cards are not terribly reliable compared to hard disks or internal SSDs. Or if there's some kind of a terrible memory smashing bug in the app that overwrites part of the database cache. We put this command in just because one of our customers was having trouble with database corruption, which I believe was tracked down to SD card corruption. The compact command will compact the database. This is useful to run during that prepackaged database process just to make sure that your file size is as small as possible. It gets rid of unused B-tree pages inside the file. It deletes any blobs that are no longer being used. It has some flags that will tell it to prune old revisions, the revision IDs of documents, and or to purge all deleted documents. The ls command will list documents in your database, either all of them, or you can give a parameter with a wildcard in it, and it will just list the ones that match that wildcard. There's also a long form, the ls-l, that'll tell you things like the revision ID and document size and so on. And if you've got ls, then you want to have cat, right? So cat will print a document as JSON, and you can put wildcards in there too, and it will actually print every document matching that one after the other. The select command, this is where things start getting really fun. Select lets you run a nickel query against your Couchbase Lite database. And I know that Couchbase Lite itself doesn't support using the nickel syntax that you may be used to from the server, but guess what? The cblight tool does. We actually wrote our own nickel parser to make this happen. So it's not all of nickel, it's kind of the large subset of it that Couchbase Lite supports, but you can use that same syntax. So this makes it really easy to just sit down and start typing in some queries to explore the database, to look at what the results are. You can even check performance this way. And you can get the results back either in tabular form or as JSON. Now the JSON might be useful for piping to some other process to do more work on it. Export will convert an entire database into JSON. You can either create a single JSON file in which every document is one line separated by new lines, or you can tell it to make a directory, in which case it's going to create a file for each document in the database, a separate JSON file. And the opposite of that is import. So that will read one of these JSON files or JSON directories and add every document in that to the database. I found these really useful for creating data sets. So you can write some kind of shell-based or Python-based or whatever tool that can just generate a whole data set as JSON, maybe downloading it off of Wikipedia or whatever. And then you can take that JSON and use the cblight tool to feed it into Couchbase Lite without actually having to write any native code. Push and pull are commands that run the replicator. So you can literally invoke the Couchbase Lite replicator from the cblight tool to either push the database to a server or to pull a database from a server. And again, this is something that you could use when automating your build process to create one of these canned databases. You just tell cblight to make a new database and then pull from your server into it. So with all of these awesome features, how much would you pay for a tool like this? But wait, there's more. You also get a serve command. This runs a simple HTTP server that is running a subset of the REST API that appears in Couchbase Sync Gateway and the original CouchDB. It's not everything in that API and doesn't support like every possible mode of every REST command, but it's a pretty good subset of it and it's quite useful. So you can run this and then have a server. You could have some other process that interrogates your database, like a QA thing maybe, to read documents or create documents. You can tell it what port to serve on. You can, I believe in the current version, you can tell it to use TLS for serving. So what is supported? You get the CRUD operation. You can create, read, update, delete documents. You can do all docs to list all of the documents. You can even start and stop the replicator from a REST call. It's that _replicate REST endpoint. It doesn't support views or queries, anything like that. That would be fun to implement. I would love to do a REST command where you could send it a nickel query and get results back. It's just never been implemented, so patch is welcome. This is not as mature as the other commands, so not everything may work quite right, but it has still proven itself to be pretty useful. So again, the URL for downloading is there. Note that it's at Couchbase Labs on GitHub, not Couchbase, because that's where we keep our more unofficial stuff. And that's it. Thank you very much. I hope you found this information useful.